Hello everyone, welcome to Mthobisi Mathematics and Physical Sciences YouTube channel. And today we're looking at grade 12 mathematics paper 2 from the June exam that was written this year, 2025. And our focus question will start from question 3, which was analytical geometry question. Given in the diagram, PQR is a triangle that has vertices P, Q, and R with the given coordinates, and PT being perpendicular height of the triangle PQR. The first question that was asked is determine the length of QR, which is 2 marks. That's 3.1.1. Now in 3.1.1, they want to determine the length of QR. Now that's QR length. Do we have the coordinates of Q? Yes. We have the coordinates of R? Yes. If we can quickly go back to the question, you can see Q is 1 is to negative 1 and R is and 9 is to negative 5. So simply plug them in here as 1 is to negative 1 and 9 is to negative 5. Then always labeling x1, y1, x2, y2. Now the length of QR can be given by the distance formula x2 minus x1 squared plus y2 minus y1 squared. Simple substitution, since we have labeled your x2 is a 9 minus 1 squared plus a negative 5 minus negative 1 squared. And you just punch everything in the calculator in order to get a 4 root of 5. 4 root of 5 is the value of QR. And 3.1.2, they're asking us to calculate the gradient of PR. Now we are given P and we're given R, so this one should also be simple. P is the point, 5 is to 2. R is the point, 9 is to minus 5. And then we can change this to x1, y1, x2, y2. We're looking for the gradient now. Gradient of PR will be equal to y2 minus y1 over x2 minus x1. Substitution is a negative 5 minus 2 over a 9 minus 5. Punch that in a calculator, you're going to get a negative 7 over 4. 3.1.3 says calculate the equation or determine the equation of PT. Now PT is that perpendicular height from QR. Equation of PT. So 3.1.3 equation of PT. We said that PT is perpendicular to QR, which means the gradient of PT times the gradient of QR will be equal to a negative 1. So we can calculate the gradient of QR since we don't have the coordinates of T. Therefore, to calculate the gradient of QR, we can still use the same coordinates of QR, which is 1 is to negative 1 and 9 is to negative 5. Label them x1, y1, x2, y2. Now calculating the gradient of QR, that's y2 minus y1 over x2 minus x1. And thus, this gives us a negative 5 minus negative 1 over 9 minus 1. And if you punch that in the calculator, you're going to get a negative 4 over 8, which is equals to a negative half. We're not done because we're looking for the gradient or equation of PT, which when you multiply with the gradient of QR, you get negative 1. So gradient of PT multiplied by a negative half will give us negative 1. So if we can divide both sides here by negative half, we're going to get that the gradient of PT is equals to 2. Now, with that being said, we know one point at P, which is 5, is to 2. We can use it to calculate the equation using y minus y1 equals to mx minus x1. Right, so y minus 2 is equals to 2 times x minus 5. Then y minus 2 is equals to 2x minus 10, and y is equals to 2x minus 10 plus 2. And if we are done here, y is equals to 2x minus 8. 3.14, the coordinates of t. Coordinates of t. 3.14. Let me just go back to the question. As you can see, t in here is where the line of PT and the line of QR meet. So you know what happens at an intersection. So what do we have for now? We need the equation of QR. Equation of QR. We also need the equation that we created of PT. Equation of PT to equate both of them. So the one we calculated is y is equals to 2x minus 8. Now we want the one for QR. So we're just going to use Q and R as, well, we did calculate the gradient of QR. So we're just going to need Q, which is 1 is 2 minus 1. Calculated the gradient of QR here in 3.1.3, and the gradient of QR was given as a negative half. So m QR is equals to minus 1 over 2. Now we just use y minus y1 equals to mx minus x1. So y minus negative 1 equals to negative half x minus 1. But that is going to give us a y is equal to, or y plus 2 is equals to negative half plus half, and y is equals to a negative half x plus a half plus 2. Oh, it's plus 1, not plus 2. This is plus 1, and now this becomes minus 1. Okay, just eraser. It's plus 1, then here it's going to be a negative 1, such that y is equals to negative half x minus a half. Right? Now we have two equations here. We'll call this one equation 1 and this one equation 2. Now those two equations intersect at point t. So equation 1 will be equal to equation 2, whereby equation 1 is our 2x minus 8, which is equal to negative half x minus a half. So 2x plus half x is equals to an 8 minus half. We are going to get here 5 over 2x equals to 15 over 2. We divide both sides by 5 over 2, and we get that x is equals to a 3. What do we do with the 3? Now we can put it in any of the equations. So I'll use y is equals to 2x minus 8. Substitute the x value to be 3 minus 8. We get a 6 minus 8, which is equals to -2. And therefore, coordinates of t are 3 is to -2. Right. 3.15. Determine the magnitude of angle R from the triangle QRP. So there's like 4 different ways, and I chose the longest one to do this one, of which is cosine rule. I decided to just use cosine rule, and then I discovered you can actually just use your trig ratios. Maybe we can try one of them and then the rest shall follow. All right. If we use for 3.15, if we say that this is P joined with Q and R, then there you have, we're looking for this angle here. You know the length here is 4 root of 5. So which means now we must get the length of PR and the length of PQ. Getting the length of PQ should be easy because you know P is 5:2 and Q is 1:-1. Calculate the length using x1, y1, x2, y2. Now PQ formula x2 minus x1 squared plus y2 minus y1 squared, which is going to be equal to the substitution of 1 minus 5 squared plus -1 minus 2 squared, which is equals to a 5. Next up, we know now this one is a 5. Last one, we calculate the length of PR. Same thing, P and R. Now point P is 5:2. R is a 9:-5. Label them x1, y1, x2, y2. Calculate the length of PR to be x2 minus x1 squared, y2 minus y1 squared. Then we substitute, and when we substitute, we're going to get 9 minus 5 squared plus -5 minus 2 squared. This is equal to, if you punch it in a calculator, you get square root of 65. Now, I always like coming back here. So if we're looking for this angle, we're going to use this side as side A and this side as side B, therefore this side is side C, so that we can use our cosine rule formula that says A squared equals to B squared plus C squared minus 2BC cos of A. Then we label that to PQ squared equals to PR squared plus QR squared minus 2PR multiplied by QR cos of angle R. Then the next thing is substitution. Calculated PQ to be the value of 5 squared equals to square root of 65 squared plus 4 root of 5 squared minus 2 times square root 65 square 65, and then it's 4 root of 5 cos of R or angle R. Now, since this one is the negative one, we move it to the left, and we're going to get 2 root 65 times 4 root of 5 cos of r or angle r equal to square root 65 squared plus 4 root of 5 squared minus 5 squared. Okay, then now we can divide both sides here by 2 root 65. We're keeping on with the values here unsimplified because we want to not lose any decimal. And here we can divide with 2 root of 65 since we are not in the final answer also. That's 4 root of 5. Then now we'll be left with cos of angle r. You punch this in a calculator, the whole fraction on the right hand side. You're going to get 3 root of 13 over positive 13. And then to get angle r, you're going to say arc cos of 13 over 13. Then guess what angle do you get? You're going to get the angle that is 33.69 degrees. Okay, to save time, I won't be able to do that one for using trig ratios, but simply you can, if I can just say from this is T, this is P, and then this is R, calculate the length here, calculate the length here, then you use any of the trig ratios. For the first one, you could use tan for TR and PT. Second one, you can use PR and TR, and so forth. Okay, let's get to the last question, which is more of a grade 12 type of question. Now, they're saying that equation of two circles with centers A and B are given below, with circle A being x minus 2 squared plus y minus 3 squared equals to a 9. Circle B is x minus 1 squared plus y plus 1 squared equals to 16. Without solving for x and y, determine if the circles intersect each other in 2 points, or they touch each other, or they do not intersect each other. Show all your calculations. Right, this is how I teach this type of a question because it's always there in the last ones. So 3.2, we'll start with circle A. Circle A is given by x minus 2 squared plus y minus 3 squared equals to 9. Now we can relate this to our original equation of a circle with the center not on the origin. So it's x minus a squared plus a y minus b squared, which is equals to an r squared. I always say related to this, so this is where the value of a comes from, that is the circle center, and this should be b. So the center says that a is equals to 2 and b is equals to 3. And then now you can say my center has the following coordinates: 2 is 2 is 3. Then my r squared equals to a 9. And therefore my r, if I apply the square root here, I'm going to get plus or minus 3, of which we choose 3 because the radius is a positive value. Then for circle B is the similar x minus 1 squared y plus 1 squared equals to 16. Now x minus a squared, as we related to the general equation, minus b squared equals to an r squared. So now, in this instance, of course, a will be equal to a 1, but here we need to say y minus negative 1 in order to get to y plus. So therefore, our b value here is equals to negative 1. Then our r squared being 16 means that r is equals to a 4 after applying the square root. Now, This means that we have a center that is 1 is to negative 1 and a radius that is 4. So in this question, they are asking us to think of a scenario like this. If you have a circle here with the center here and another circle here with its center. We'll say this is circle A, so this is center A, and then this is center B. Now, they have the following radius A and then radius B. Now, if you may check, the length from center A to center B is longer since these two circles are apart. So if you get a distance between the two centers that is greater than you adding up those two radiuses, or a case whereby you have um, this, which is just touching this circle, then you check the length between those two centers should be equal to radius 1 and radius 2 because they're just touching. But if they are intersecting, if this circle intersects with this circle, this means that the radius here and the radius here, their sum will be greater. So radius A plus radius B should be greater than the distance between their centers. So the distance will be smaller, distance between centers. So from the center, so their distance will be shorter. Anyway, what do we have in our case here? We can make a final judgment. So we will need to start by adding up the two, radius A plus radius B. That radius A is a 3, radius B is a 4, which gives us a 7. Then we must calculate the distance between center of A and B using the distance formula. X2 minus x1 squared, y2 minus y1 squared. Now we have a center with 1 is to minus 1 and another center, so that's center B, center A being a 2 is to 3, then we can label them x1, y1, x2, y2. Substitution number 1. Substitution is x2, that's 1 minus 2 squared plus negative 1 minus negative 3 squared. If we punch that in a calculator, we get the square root of 17, which is 4 comma, it's 4 comma what? Let me just punch my calculator real quick. Square root of 17 is 4 comma 123. And that means radius A plus radius B is greater than the distance between their centers. Distance between centers. Centers for circle A and B. Therefore, I'll make this judgment that the circles intersect each other in 2 points. In 2 points. Right. Just on a final note, thank you guys so much for your subscriptions. We've reached 507 subscribers and our videos are over 40,000 views. Thank you so much, guys. Keep on liking, sharing, and we'll try and keep up with the pace of posting more and more. But thank you so much.